This is part 2 of my Lab 16 demo. Got cut off a moment ago, so go ahead and start in on the ArcGIS Online section of the lab. And so you launch this directly from your lab document, and because we're working in the online environment, you're just on our website. I've created this, no special login, anybody could access this. And this is the most general way to interact with ArcGIS Online. And so I just have you focusing on looking at some of these different layers. The Content tab shows you the layers that are presently active, and you can turn on and off individual layers. So we start off by talking a little bit about the climate of Canada. And the climate, there's different ways to access information. So you'll notice I clicked on the little ellipsis underneath the layer, and that throws me into this description that tells me a little bit about the way that this information was collected and what they're trying to represent on this particular layer. And for the purposes of this particular lab, I have us focusing on the environment. And so this is one reflection of the environment. And if we look at the legend, we can see that we have information that tells us what these colors indicate on the map. This is an example of a thematic map because it's covering a single theme, in this case, climate or annual temperature. And as I indicated in the lab, you can see different things that cause this pattern. And when I talk about pattern, in this case, the most general pattern to me is that we see this blue type occurring at the top of the map. We see this pattern of it. This next one is kind of shown in this middle area, and on down we go with some of these pockets of red showing along the west coast and along the border with the United States, and along the east coast and along the border of the United States. So again, we've got a pattern, and we could actually determine what the physical characteristic. I give you some examples of what you're looking for at the end of the document, my description about the physical environment. Next, we're going to look at the topo maps, and I wanted to reiterate this point that topography, or the shape of the land, can be reflected in a number of different ways. And so we're all familiar now with looking at these shaded relief maps, and we can see nicely on this map that the state of Nevada has this very interesting pattern of these, sometimes described like the caterpillars that are crawling northward, representing these elevated ranges that alternate with these downdropped basins. That's actually the product of tectonic activity as well. And of course, as we zoom in, we'll see a different rendition of the topography, one that uses contour lines, which is the familiar way that we represent things on a USGS topographic map. And so as I zoom in, this will resolve to greater and greater levels of detail. If you're buying paper maps, you might be looking at 1 to 62,500. That's a standard format. And as we get in closer still, we're going to see the traditional 7.5 minute quadrangle level of detail. And so, of course, we've got contour lines, and those contour lines label equal elevations. So I'm at the 2,400 foot contour line, and you can see where this contour line travels around. We could go up to the 2,600 foot contour line. And this is combining the shaded relief as well, which is nice for being able to interpret how the contour lines reflect themselves in terms of topography. Actually, there's the 7.5 minute. I think when I'm out at this level, I'm at the 62,500 but the 1 to 24,000 gives us even more detail. And again, you can see these nice concentric circles that correspond to this peak, this ridge line. You can see how the contours kind of distend outward. I won't be asking you to do much in the way of interpreting contour lines, but you should recognize contour lines when you see them, and you should know that they're are representing equal elevation. You can use similar lines to represent equal precipitation or temperature, other things in addition to elevation that can be represented in this fashion. Okay, so next I have you examining watersheds, and of course watersheds are a reflection of the natural waterscape that we're looking at. And I'm going to use this zoom to capability. Again, I just grabbed the ellipses. Now this is a slightly different layer, and so they give us some different options, including opening up the table and what have you. So let's go ahead and turn off the U.S. topographic map. You can just see this plain world shaded relief underneath it. Nice way to show how the watershed boundaries actually correlate to the natural drainages. You can see the rivers flow this direction from this watershed, this drainage divide. Rivers flowing the other side flow away from that drainage divide. And on any layer you can typically click on it and get information. So I just identified the upper Clear Creek boundary, and I can see that I've got acreage totals in there, and most of these other numbers are just internal codes associated with the data, not necessarily something that the user would associate with the data. So one of the things that we might be interested in doing is looking at the table of values. We can see these names, so we might be interested in locating a particular watershed. You can see that I selected the Pitt River MacArthur watershed. I might be interested in finding out which of the watersheds is the largest, so I could do a sort descending, and sure enough, the Pitt MacArthur watershed is the largest geographic watershed. So we've got some different capability. The filter actually operates on the table, and so we might be interested in saying, well, we're really interested in looking at watersheds. Let's say we're interested in looking at small watersheds. So I'm going to say those that are less than, I'm going to say 50,000 acres. And we'll apply the filter, and it looks like it grabbed just these watersheds below as meeting that condition. Notice how all the other ones disappeared, so in order to get back to that, I would need to chose the wrong option there. Again, if you hover your mouse over, it'll come up, and I can say remove filter, and all the watersheds return. Okay, so that's mostly physical features, but we could also look at cultural features. So I'm going to go ahead and zoom to this particular layer. And what you'll see here is that it is covering the United States, and that it's variable depending on scale. So right now, I only see a single value for each state, and they're giving us the diversity index. Yes, not surprisingly, California is one of the most diverse states, although as we zoom in, we'll see that it's variable within the state, and not surprisingly, places like Los Angeles and San Francisco have higher levels of diversity. So now we're seeing this at a county level. These are administrative boundaries. And as we zoom in further, we're going to start to see census tracts. So this is the census tract level, and we could choose an individual census tract and get some information. In this case, they're giving us a table with an index value that's associated with each of these particular boundaries and the data associated. Okay, so this is a one of the questions is the type of map. So anytime you see a map where you've got full coverage across the landscape and you have these different areas that each have values, it's a particular type of map that you'll find on your list below for review. And I also have you examining populated places and getting a little bit of information about these populated places. One of the things that I wanted to reiterate is, my main objective is to have you reviewing the types of maps, reviewing the basic skills and how you access information about particular locations. So you might click on this particular polygon to get some information like population. And then also just to be generally thinking about what it is that you're looking at. Are you looking at physical features or human features? To be thinking about things like relationships. Okay, so here's a nice example. Is there a relationship between the location of Denver, Colorado, and the surrounding topography? And an examination of this will reveal that we have very mountainous terrain bordered by very or relatively flat terrain, and that the built areas of Denver and the surrounding cities and towns are found in this flatter terrain. It's quite common that humans build away from these steeper areas. We might come in and look at the actual drainages, some of the lakes and rivers and what have you that reflect this. Maybe look at elevation or how this landscape was formed through tectonic processes or glaciation. There's a variety of different ways that we can look at that. So I guess one of the messages as you're doing your lab is don't spend an excessive amount of time trying to come up with a particular answer, but rather to try to make sense of what it is that you're looking at. For example, topographic maps show both physical and human or built features, and as you read through this, you'll see that there are particular features that are labeled. You can see a highway symbol here. You see something that indicates power lines. And again, as a rule, when you're looking at rigid or hard lines on the map, those tend to be built features versus the more messy natural features. So you've got colors and lines that are going to be reflecting natural features on the landscape. If you zoom in far enough, you'll get beyond the zoom tolerance. And in this particular map, you don't actually have a legend that goes along with it. So some of this you'll have to infer. You actually can look up the USGS topographic map symbols, and this will show you how to interpret the specific things that you're looking at on the map. If you're having trouble identifying or if they're not labeled, you can choose that as a route. All right, well, that's my summary, and I'll look forward to seeing you all online for a exam review discussion in advance of our exam next week.